Hello YouTube and welcome to another video. This is basically part 2 in a series where I am building a carbon fiber bed plate for my Kawasaki jet ski. The jet ski in question is a 1990 Kawasaki X2 that I am swapping an 1100 triple in that was donated to me by the Jet Ski Brothers. After doing a whole lot of work on this ski, if you're not up to speed, check out my other videos. I found a little bit of a crack in the original bed plate, and wanting to save a little bit of weight and try my hand at vacuum infusion, I decided to go ahead and build a carbon fiber bed plate just to see if I could do it. Turns out somewhere along the way I had a little bit of common sense come over me and decided to build one out of fiberglass first to see if I could actually do it. And so that's what this video is. Part 1 and 2 are going to be me building this thing out of fiberglass. It's actually sandwiched in between a few layers of carbon fiber so I can see what the finish turns out like. That is the video that you're about to watch. Let's get into it. I came out at 9 o'clock in the morning and checked on this, and it was still holding about 25 inches. It's about 23 and a half now. That is good. I am going to mix up some epoxy. I'm going to think about this carefully. I'm going to try to remember to time lapse it and actually get a shot of the epoxy going across. I'm a little bit nervous, but also quite excited about what's going to happen next. Even if this is a complete screw up, at the very least, I will have learned a few things. So hopefully it turns out. It'd be really cool to see what this bed plate can do in fiberglass. It'd be, yeah. Anyway, I'm just going to get to it, start mixing up some epoxy. I have the Hero 9 set up, recording time lapse over here. And I have the part ready for epoxy. I'm going to use the timer on my phone to try to pull about half an inch a minute of epoxy across the part. So it should take about half an hour, maybe a little less, to pull the epoxy all the way across. I've never done this before, so it is going to be a little bit nerve-wracking. I'll try to film a little bit with the Hero 7. But I don't know what I'm going to actually capture. That's why I have that set up doing time-lapse. I'm about to mix up the epoxy, and I'm actually going to do 300 grams at a time. I'm not sure how much epoxy this part is going to take, and so I think it's going to take about 600 grams. So what I'm going to do is mix up one batch, pour it into the cup over there, start infusing, and then when I notice that is starting to get fairly low, I'll mix up another batch based on how far it's actually gone across the part. I'm not going to be stingy with it because I want to make sure that it doesn't pull any air, because if it does, that's definitely bad. It's going to ruin the part. All right, I've been stirring the epoxy for 2 minutes. I'm going to stir it for another 2 minutes to make sure that it's really well stirred, because I definitely don't want any unevenly mixed epoxy going in here. I probably should have set it up so that I could pull a vacuum on this stuff and degas it, but I honestly don't think it's going to make that much of a difference. I'll let it sit for a couple of minutes before I actually open the valve and let some of it bubble off. I'm a little bit nervous, not gonna lie. I'm a lot nervous. It looks like I had this clamped for so long that it doesn't want to open up. There we go. Oh, I don't know if the camera picked up on that, but we've got flow. You can see it working its way all the way down here. Oh, it's coming in already down here. So my lines are working. Okay, I gotta crank it way back. It's flowing too fast. Seems to be going fairly well. You can see it's getting quite close to the line here. I'm kind of concerned about that because once it reaches here, it might start just pulling epoxy through. It is now 3:15. I'm not sure exactly when I started this, but it appears as though it went pretty well. The main thing that I'm concerned about, which I've probably said 5 times already, is that it didn't even use 600 grams of epoxy, so we've got a little bit left in the cup there, and some that it's actually sucked through here, and it's still sucking some through. So my concern is that it may be wet out on the surface that we can see. We know that it's wet out here because we can actually see that. But what we can't see is that if it went all the way, all the 6 millimeters through to the mold surface. And so the only way we'll know that is when we pull it apart tomorrow, I guess. And yeah, then we'll find out if this worked or not. I'm going to continue allowing epoxy to get pulled through. I've trapped it off here. And I allowed a little bit extra to flow into this side. Even after it was coming out here, I let a bunch come through. And what I'm doing is basically allowing it to continue to pull through into the pot. I should probably turn the pump back on soon here. Actually, it is still 26.5 inches of mercury. Oh, a little bit splattered. A little bit splattered on the glass. Interesting. Okay, anyway, I forget exactly what I was saying. Oh yes, I'm going to allow it to continue pulling through just so that hopefully I get it wet out all the way through. That's all I have to say for now. I'm probably going to want to come back and say a whole bunch of stuff that will never end up in a video, because basically all there is to do now is to wait, and I don't like waiting. The reason why I actually turned the camera on last time was to say that I realized that I was going to get some sort of a mechanical lock on the back side by putting the breather on here. I knew that the epoxy was going to go around, but I think it actually is going to be a little bit worse than I had anticipated. So I don't think I can get a shot of it without potentially ruining anything, but the breather cloth goes underneath and around this edge, and so yeah, basically the consumables, when I'm removing them, are going to be very tricky to get off. I'm probably going to have to use a grinder and trim along the edge of the mold here in order to try to make the viscosity of the epoxy a little bit lower and help get some of the air out. I took a couple of light bulbs and put them in sockets and put them underneath the bed plate here, and it warmed it up quite a bit. I think actually maybe a little too much. I used 2 100-watt light bulbs and it got it very hot. Anyway, I can see that it is actually working somewhat. I could see big bubbles of air getting pulled through in a few places, so it obviously worked to some extent. I'm done using the scale. I guess we'll take the battery out of the scale. That's what kind of operation we're running here. Only enough budget for one 9-volt battery. You got to put it, switch it around in different tools. The epoxy in the cup has flash hardened. It heated up quite a bit, and then oh yeah, 210 Fahrenheit. 222 Fahrenheit was the highest it recorded. This is actually quite promising, because if the epoxy is able to make its way all the way through here and it's actually infusing the back side of this in the breather cloth, that means the process is working fairly well, I would have to assume. So what I'm actually going to do now is turn the vacuum pump off. So I'm going to close this up. I'm going to let the pump breathe a little bit. I don't like shutting it off under vacuum. And in a little while, what I'm going to do is I'm actually going to pinch this line off and leave it alone. I'm kind of nervous to do that, but I think it's the smart thing to do. It is now about 9 p.m., which means it's about 6 hours after I finished infusing the part. And even though the resin has hardened up quite hard in the cups, and the exothermic reaction seems to be done in both of these cups, I guess you guys can't see that. The cure of the epoxy, I think they say it at 150 Fahrenheit, it's 8 to 10 hours. So yeah, I've got the light under there still heating it up. It's keeping it about, I guess it depends where you measure it, but it's about 145 there, and it's only 96 down here. So it's going to take quite a while, but the good news is it held the vacuum It is currently 1:03 a.m. and I'm about to shut the light off because I'm going to go to bed here soon. And it's looking promising because the second batch of epoxy that I did, which I didn't even mention to you guys, not the second batch, the third batch, I added an extra 50 grams because I thought I might have to use it. So I actually mixed up 650 grams, and the third batch is sitting on top of the box here, and it's actually hard enough, it's not tacky, and I can break it off with my fingers. So that is very promising. The stuff in the cup is obviously quite hard. That feels quite solid, but yeah, I'm gonna unplug this and leave it. It still has a good vacuum on it. It's 26 inches of mercury. All right, I guess we do this. I hope this doesn't sound like a really weird, crazy thing to say, but this is a bit of a surreal moment. I watch videos of people doing this, and I always think to myself, that's something that other people do. That's not something that I do. So to have gone through this whole journey up to this point, and now I'm doing this. This is the big moment where you pull the part out of the vacuum bag and see the results of what you did. Of course, I hope that this part worked out. But regardless of it, if it worked or not, this is still a really big moment. So right to the end. All right, I can see that I got a tiny bit of bridging along here. It looks like it did get wet out. All right, I found these wedges. These are used for shimming windows and door frames and whatnot. Bought them years and years ago and never used them. I'm hoping that I can drive some in the edges here and this will peel off. Don't know if the camera can hear that, but there's some crackling noises. Those are good noises. All right, I'm going to try tripling up on these. Take this one out and put 3 in. Do the same thing on this. Oh, there it comes. Oh, there we have it. There we have it. Okay. Please please have worked. Oh, I'm so scared right now. It feels very sticky underneath here. And I feel like it's the epoxy, but it could be the tack spray that I used. All right, let's find out if this worked. I'm gonna show you guys, and I'm not gonna see it yet. Please work. Ooh, it looked like it might have worked. It actually pulled some of the epoxy out here because it's stuck, but I think it worked. Oh my God. Oh my God. It smells very fresh epoxy-like. I'm kind of nervous that it's not totally cured, but wow, that is gonna work. I need to trim it up. I think I'll do the trimming off camera and then come back. Wow, it worked. Holy crap. All right, I got it trimmed up a little bit, and even though initially it seemed like a success, I'm a little bit confused. The thickness isn't right. So what I'm going to do so I can actually measure it is I'm going to drill out the holes, but I think what happened was I did some calculations using some material and then I switched and used a different material. So that's the only thing I can think of. I need to do the math again, but before I do any of that, I'm going to drill out these holes. Oh man, that kind of sucks. I mean, it doesn't matter too much, but I was getting ready to drill out one of these holes and the battery on the camera died and it distracted me, and when I started drilling again, I drilled these holes instead of these ones. Not a big deal. I was going to drill these ones out slightly smaller. I wanted these ones to be 1/2 inch, but these ones to be closer to 3/8. But not a big deal, I guess. All in all, it looks pretty good, but it is definitely only about 4 millimeters thick. The original plan was to chop these out once it was finished, but I think I'm actually going to leave those in and just drill some holes for the water to drain out of. All right, here's something that I'm very curious about, and this kind of doesn't matter because 1, it's mostly fiberglass, and 2, it's thinner than it's supposed to be for some reason, but I'm going to pop this on the scale and we'll compare it to the weight of a steel one. 1 pound, 7.8 ounces, 676 grams. Yeah, it's over 5 pounds. So I'll get my other scale. 2.5 kilograms. Who cares about newtons? 5.5 pounds. It is now several days later. I believe the last clip that you guys saw was either Wednesday or Thursday of last week, and it is currently Monday. We went away for the weekend and visited some friends, and that's why I didn't have a video out for this Sunday. This part turned out really well. I was able to drill all the holes in it, including the drain holes, which I believe you guys already saw, and I was able to clean it up. What I did off camera was leveled out the surfaces for the motor mounts on the back side, and the finish turned out extremely well. I'm very happy with it, and it has given me the confidence to go ahead and build a carbon fiber version of this. So I am very excited about that. The only kind of downside to this, or the only downer about this, is that This part was supposed to be 6 millimeters thick, or at some point in my mind I thought it was going to be 6 millimeters thick, but it is actually only 4.2 millimeters thick, and I know exactly why. I've kind of already explained it in this video, but I will tell you guys exactly what happened now. So when I was going to build this motor mount, I originally planned to build it out of carbon fiber, and the carbon fiber was going to be 6-ounce twill and a 1 millimeter thick unidirectional. I don't know, I think it's 23 ounce or something like that, but it is unidirectional carbon and it was 1 millimeter thick. So I calculated how many pieces I was going to need and put it all together and figured out exactly what I was going to do. And then I decided it was a really stupid idea to build one out of carbon fiber without having ever used the resin infusion process before in my life. So I decided to build one out of fiberglass. When I decided to build one out of fiberglass, I didn't have unidirectional, so I decided I was going to use woven roving, which was 0.5 millimeter thick. So the unidirectional 1 millimeter was going to be replaced with 2 pieces of woven roving at 0.5 millimeters thick, which should have just worked out perfectly. But what happened was I didn't have enough of the 6-ounce fiberglass cloth to stagger the layers. The way I wanted to do it was have 2 layers of 6-ounce and then the woven roving, and then 2 more layers of 6-ounce woven roving, so on and so forth, until I had it as thick as I wanted it. The problem was that I didn't have enough of the 6-ounce, and so I decided at some point that I was going to make it 4 millimeters thick. Then I took a break from the project and did a bunch of other stuff, including skinning the hull and doing some work on the engine and whatnot, figuring out some electronic stuff. And then I came back to this and I decided, you know what, instead of just building a pure test piece, what I'll do is I'll make one of these that can actually be torture tested, and I'll send it off to the Jetski brothers. They have all sorts of Kawasaki's, and I'm sure they would enjoy beating on one of these or just using it. So the idea was, when I started making this, actually laying it up, was that I thought I was making a 6 millimeter part, but because I didn't add those extra layers of woven roving, I ended up with a 4 millimeter part, or what turned out to be 4.2 millimeters. And so yeah, now I have this part that looks really nice and is only 4 millimeters thick, so I'm not really sure what I should do. I kind of feel like I should keep this as a souvenir, as my first resin infusion part ever made, and just hang it on my wall, because it is quite a beautiful piece and it did turn out quite well. But at the same time, I kind of feel like I should send it to the Jetski brothers and have them test it, and if it breaks, it breaks. Yeah, I really don't know. I keep changing my mind on what the best idea is for this. Maybe you guys should let me know what you think I should do with this in the comments. Maybe the Jetski brothers should let me know if they're actually willing to test this if I wanted them to, because I guess I shouldn't just say that they're going to test this without actually even asking them if they want to. But yeah, I haven't fully made up my mind. It would be kind of a shame to ruin this part, but at the same time, it'd be neat to see it used. Even if it did break, it wouldn't be a, you know, complete catastrophic thing where the engine flew out through the side of the hull and there was a giant explosion. I am extremely happy with the way this thing turned out. I very honestly did not expect my first go at vacuum infusion to turn out this well. As you guys who watch my videos will know, I was quite nervous about doing this, and the reason why I made the fiberglass one in the first place was because I didn't want to waste a whole bunch of carbon fiber material. This has now given me the confidence to go ahead and make one out of carbon fiber, and I am extremely excited to do that. I still am quite nervous because the process is going to be a little bit different during layup because I'm using unidirectional carbon instead of the woven roving, but I'm sure I will be able to figure that out. So, a few of you have been asking me whether or not I'm going to make and sell these, and a lot of that depends very much on what the final cost of this ends up being. Because I made this one mostly out of fiberglass, I still have no idea what the carbon fiber one is going to cost me, and it might just end up being so expensive to make that I wouldn't be able to make any profit off of it. And as much as I do enjoy doing this stuff, I can't invest that much time and money into something that I can't sell at a profit. So I will have to actually make one out of carbon fiber, figure out what the total cost on this would be, and then figure out if it is something that people are actually willing to pay for. So, with that being said, this video has gone on for quite a while, and as much as I do want to sit and just stare at this, I did take this thing camping with me. And tried to show it to a few people, but nobody quite had the interest in it as I did. I'm trying to end this video, but this thing looks amazing. I am so excited about the way this turned out. Anyway, this video does have to end at some point, so I guess that is going to do it for this one. Thanks for watching, and I'll see you next time.